Welcome to Understand the Math. In this video, we're going to learn about the 7 laws of exponents, essential rules you'll use when working with powers. I'll explain each law and go through examples for each one, and then we'll put them all together with 2 practice problems that use multiple rules at once. Let's get started. We'll begin by going through each of the 7 laws of exponents and look at examples for each one. The first one that we're going to look at is called the product of powers rule. This law tells us that when we're multiplying like bases that are each raised to a power, all we need to do is add the exponents. Let's look at some examples to make sure that we understand how this works. In our first example, we have x to the 5th times x squared. They both have the same base, and that base is x. So all we need to do is add the exponents. So we're going to add 5 plus 2, and then we get an answer of x to the 7th. The second example that I have here has a constant as a base. So our answer is just going to be 2 to the 2 plus 3. We're just adding the exponents, and that gives us 2 to the 5th. This is just 2 times 2 times 2 times 2 times 2. Lots of 2's. Let's see here. This is 8, and this is 4. So our answer is 32. Let's look at one last example before we go on to the next law, because this example has both constants and a variable in it. What we want to do when we have this combination is we want to multiply the constants first. So this is just 8 times x cubed times x to the 7th. Now we're going to add the exponents, and our answer becomes 8 times x to the 3 plus 7, and that's just equal to 8 times x to the 10th power. The second law that we're going to look at is called the quotient of powers rule. This law tells us that when we are dividing like bases, all we need to do is subtract the exponents. Now, if the power in the denominator is bigger than the power in the numerator, what you do in practice is write the answer as 1 divided by a to the m minus n. The reason that you do this is it's easier when you're working with positive powers. Let's make a note that you write it this way if n is greater than m, and then you write it this way if m is greater than n. Let's look at some examples. In our first example, we have x to the 5th divided by x squared. The power on the top is bigger, so we're going to write this as x to the 5 minus 2, which is just x cubed. Let's now look at our second example. It has constants in it. The constants are the same, so we can write this as 3 to the 6 minus 4, which gives us 3 squared, which is just equal to 9. In our third example, we have constants and variables, so let's work with the constants first. 12 divided by 3 is 4, and then we have x squared on top, and then on the bottom, we have x to the 8. Notice that the power on the bottom is bigger than the power on the top, so we are going to write this as 4, all divided by x to the 8 minus 2, which is just 4 over x to the 6th. The third law is called the power of a power rule. When we raise a power to a power, all we have to do is multiply the exponents. In our first example, we have x to the 5th squared, so this is just x to the 5 times 2, which is x to the 10th. And then our next example, we have a constant. It's 2 squared cubed. So this becomes 2 to the 2 times 3, which is 2 to the 6th, which is equal to 2 times 2 times 2 times 2 times 2 times 2. Let's see here. This is 8, and this is 8. So this gives us an answer of 64. Let's now look at our fourth law. It's called the power of a product rule. When we have 2 factors, a and b, that are raised to a power, we're going to distribute our exponent m to each factor inside the parenthesis. Let's look at an example. We have xy squared, so the 2 is going to be distributed to both the x and the y, and we can write this as x squared, y squared. And then the same thing is going to happen when we have a constant and a variable. Our power of 3 is going to first get distributed to our constant, so that's 2 cubed, and then we have x cubed, and then 2 cubed is 8, so our answer is 8x cubed. Law number 5 is called the power of a quotient rule. This is similar to the one that we just looked at, the power of a product rule. When we have two factors that are divided and raised to a power, all we have to do is distribute our power or our exponent to both the numerator and the denominator. In our first example, we have x divided by y quantity squared. So our 2 power is going to be distributed to the x and the y, and this becomes x squared all divided by y squared. And then the next one is very similar. We're going to distribute our 3 to our x, so this is x cubed divided by 2 cubed, and this becomes x cubed divided by 8. Hang with me, we only have 2 more laws to go over, and honestly, I think they're easier than the ones we've already gone over. When we finish these, we'll put everything together and go through 2 practice problems. Our 6th law is called the zero exponent rule. This rule just tells us that any non-zero base raised to the 0 power is equal to 1. In our first example, we have x to the 0, so that's just equal to 1. So that's a variable raised to the 0 power. Now we have a constant 5 raised to the 0 power, and that's also equal to 1. Now we're on our last law. It's called the negative exponent rule. This rule tells us that when we have a base raised to a negative exponent, all we have to do is put the base in the denominator and then change the sign of the exponent. Let's see how this works. If we have x to the minus 3, this is just 1 divided by x cubed. And then likewise, 2 to the minus 4 is just 1 divided by 2 to the 4, which is 1, all divided by 2 times 2 times 2 times 2, which gives us 1 divided by 16. Let's now put all of these laws together and look at 2 practice problems that are similar to problems you may be asked to solve. Let's look at our first example. We are asked to simplify this really complicated looking algebraic expression. Don't worry, we'll break it down into pieces. Let's begin by writing down the problem. That's always a good place to start. We are being asked to simplify 6x to the 5th, y cubed, all divided by 2x squared y to the 4th, all raised to the 2nd power. The first thing that we're going to do is work with the constants. We have 6 divided by 2, and that's equal to 3. Now we're going to combine powers. Let's look at our x's first. We have x to the 5th divided by x squared. The 5 on the top is bigger than the 2 on the bottom, so we're going to write this as x to the 5 minus 2. Now let's look at the y's. Our y on the bottom has a power of a 4, and that's bigger than the y cubed on the top. So we're going to keep the y in the denominator and write this as 4 minus 3. And all of this is squared. We'll simplify before we go ahead and square it. So on the inside, we have a 3, and we have x to the 5 minus 2, which is 3, and then y to the 4 minus 3, which is just y. Now we're going to square everything. So this becomes 3 squared times x cubed squared. So remember, we're going to multiply those two numbers. And then in the denominator, we have y squared. So our final answer is going to be 9x to the 6th, all divided by y squared. And that is much nicer than the expression that we started with. Let's do another example. I chose this one because it has a negative exponent in it. We'll start by writing down our problem. We have a minus 10 x to the 4th y, all divided by 5x squared y to the 4th raised to the minus 2 power. I always tell my students, whenever you have a complicated expression and you write it down, before you go on, just double check that you've written it down right. And we have, so we can go ahead and go on. Let's work with our constants first. We have a minus 10 divided by 5, so that gives us a minus 2. And now we'll work with our x powers. We have a 4 on the top and the 2 on the bottom. So we're going to write this as x to the 4 minus 2. And then for our y's, notice that we have a bigger power of y on the bottom. So we're going to keep our y on the bottom. And we have a y to the 4 minus 1. And this is raised to the minus 2. Before we work with our minus 2 power, let's clean up what's inside. So this becomes a minus 2 x squared, all divided by y cubed. And that's raised to the minus 2 power. When we have a negative exponent, we need to switch the numerator and denominator. We can write this as y cubed, all divided by minus 2x squared. We're just changing the numerator and the denominator. And then now, instead of a minus 2, we change the sign and we have a plus 2. Now we can go on and simplify. This becomes y cubed times 2. And then we have a minus 2 quantity squared, and then x squared times 2. Let's give us a little bit more space here. This becomes y to the 3 times 2, which is 6, all divided by minus 2 squared. So that's just minus 2 times minus 2, which is 4. And then we have x squared times 2, so this is x to the 4th. And that's our final answer. And that's it. Now you know how to use the 7 key laws of exponents. With some practice, these rules will start to feel natural and easy to apply. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.